So hi everyone, welcome to 2025 AIB. We are officially going to start the meeting, and as a reminder, this meeting is being recorded as public record, and that participation in a recorded meeting will be deemed as consent to be recorded, including statements both written and oral. Public records, including this meeting recording, can be requested at any time in accordance with the Vermont Public Records Act. So thank you all for joining us. We're going to start with our introductions. And so I think I'm going to start with people in the room here with me. I don't know if the camera will go around, but I'm going to start by saying, I'm going to start with our newest member. Leon Korse is here today. So we said goodbye to Brian Kemp as our organic farmer representative and at the end of 2025 and 2024. So we welcome Leon Korse here today, who's filling that spot for us. So thank you very much. So Leon, if you want to give a quick introduction to yourself, that'd be great.
I'm Leon Korse. I'm a fifth generation dairy farmer. We were certified organic in 2008, so we've been organic for 17 years. We milk about 55 cows at a high elevation farm. We're located about 2,000 feet above sea level. And I am involved in various agricultural organizations. I have 3 positions in Crop Cooperative, which is the parent company of Organic Valley. I'm on the board of directors of the Dairy Grazing Alliance, which is the parent of the Dairy Grazing Apprenticeship Program, if you've ever heard of that. I am on the board of a farm supply cooperative, and I've been the town of Whitingham moderator for 40 years. So I'm a little bit familiar with running a meeting. And I'm happy to answer any questions that anyone has about my background.
Well, we certainly welcome you and glad you're part of the group.
Thank you.
Thank you. I'm going to continue just around the room here. Steve, why don't you go?
Yeah, Steve Doynell, Director of the Public Health and Agricultural Resource Management Division of the Agency of Agriculture, Food and Markets, and a member of the board.
Stephanie Smith. I work in the Public Health and Agricultural Resource Management Division. I'm not a member of the board, but I'm staff.
My name is Pam Breyer. I am the agrochemical toxicologist with the Agency of Agriculture, Food and Markets, also not a board member.
And I'm Morgan Griffith. I am a board member. I'm also kind of just your organizer and point of contact for any questions. Always feel free to call or email. So I am going to go through our members that I see first on the list. So Amanda, just a quick introduction.
Sorry, everyone, having technical difficulties. Amanda St. Pierre. I'm a dairy farmer up in Berkshire, Vermont with my family and a member of the Vermont Dairy Producer Alliance.
Thanks. Roy?
Hi, good afternoon. Roy Beckford, Associate Dean in the College of Agriculture and Life Sciences at UVM and Director of Extension. Good to see everybody. Happy New Year.
Thanks, Roy. Thanks for joining us. Pamela Wadman.
Hi, I'm Pam Wadman. I'm with the Department of Health. I'm a toxicologist and risk assessor, and I am a board member currently. And I'd also like to take this opportunity to introduce our new toxicologist with the Department of Health, Dr. Andrea Kirk. I see you're on, Andrea. Thank you.
Sure, Andrea, go ahead. You can give a quick introduction, please.
Sorry, I didn't realize I was muted. I just want to say hi.
Sorry.
I'm the new state toxicologist, and I'm glad to meet everyone.
Thanks for joining. Our next person I want to introduce is Sean Lucas. He's joined us for the last couple weeks. Last meeting, 2 meetings maybe. So I do want to say, so Wendy Sue's not with us right now. She's on vacation, and she actually has completed 3 consecutive terms because your term when we first started the AIB. And so because she's served 3 consecutive, we have to switch her out. So we are lucky to welcome Sean Lucas as a member, probably starting at the end of February as an official member, even though he's been participating. So Sean, go ahead and give us a quick introduction.
Hey, Sean Lucas, UVM Extension. I am the Extension Agronomist in the Middlebury office. Fairly new to Vermont. Been here about 6 months now. But my background is soil biology, soil health, and a fair bit of experience in organic agriculture. So super excited to roll onto the board and appreciate the work that has been done before me. And I probably need to catch up with Wendy Sue and just and get some grounding from her before I officially roll on.
Sure. Yeah, we have time for that. Wendy
Cool.
Sue definitely was feeling very sad that she was going to be away for this meeting. And so we can definitely make that transition easy for both of you.
Yeah.
So, thank you.
Love to connect with her. All right. Thank you.
Okay, I think that's all I see right now for members. So I'm going to go through introductions of others on the call. So I'm just going to go down the list. So Patty.
Hello, everybody. This is Patty Casey. I'm in the farm division as well. I'm not a member of the AIB. I oversee tick and mosquito vector-borne disease issues statewide, and I supervise Brook and the apiary program, and also I'm responsible for pesticide monitoring in ground and surface water around the state.
Thanks, Patty. Brooke, go ahead.
I heard my name, so I figured I should say hi. My name is Brooke Decker. I also am in the farm division, not on the board, and I am the pollinator health specialist. I work a lot with honeybees.
Thanks, Brooke. Who is called in with the phone number 2326? Oh,
Can you hear me?
yes, I can.
Hi, it's Nate North.
Hi, Nate. I thought that might be you. I'm sorry I missed you with the member call out,
okay.
but go ahead. You can give a quick introduction.
Nate North Consulting, just divesting from Massachusetts and my residence now in Montgomery, Vermont. I've been in the berry industry over 40 years, and I work with berry growers throughout North America.
Thanks, Nate. Dylan?
Hello, everyone. I'm Dylan Gabbert. I'm with Crop Like America and Rise. It's good to see everyone.
Thanks. Emily?
Hey everyone, I'm Emily May with the Xerces Society for Invertebrate Conservation. I'm probably a familiar face by now. Agricultural conservation lead with our pesticide program, and I work with growers and field staff around the country on pollinator-friendly practices and reducing pesticide risks to beneficial insects. Thanks for having me.
Thanks, Emily. Jill?
Good afternoon. My name is Jill Goss. I'm an agricultural input specialist with the Agency of Agriculture, Food and Markets.
Thanks, Jill. Ross, Conrad?
Yeah, hi, Ross Conrad. I'm a beekeeper out of Middlebury. And so as you can imagine, pesticide issues, I'm very sensitive to them. And sometimes I'll pinch hit for Brooke, helping out with bee inspections in Vermont.
Thanks for joining us. Ross Saxton?
Hey there, I'm a water quality specialist in the water quality division. Kind of been just doing some background research on what's going on with neonics, as several farmers have shared with me their concerns about not growing cover crops once the neonic seeds are no longer allowed except for the exemptions. So I'm just kind of staying apprised so I can learn more and hopefully share some info on that with farmers going forward.
Thanks, Ross. Zach?
Zach Schakowsky, Agency of Agriculture, Farm Division.
Thanks, Zach. I think that I got everyone that I see. Did I miss anyone? Great. Well, thank you very much for joining us. And so we have a few things. First, one thing is I sent out the minutes to the members from the December 9th meeting. I didn't hear of any adjustments or additions, and so those are up on the website along with the recording and any materials that we discussed that day. So the first thing that we wanted to kind of give you an update on is that we had to submit our annual report to the legislature, and so I sent that out, but I'll go over it with you here. Just share my screen. So basically, it took the same form as what we've submitted the past 2 years. So it's due on the 15th of January every year. And so it basically just went over our learnings from the year. And so obviously this year, again, we were heavy on learning about neonic treated seeds as well as neonic pesticides in general, and how we used those learnings to create recommendations for how these best management practices should be drafted and into a rule. So learnings that we went over are all of the key presenters that we had, but also it went over the best management practices that you guys ranked from your survey to say, yes, these are priority best management practices. Also included the best management practices that you members wanted to include from the public comment that was submitted by Xerces Society, to put those recommendations to include in the rule also are outlined in this report. And then we have every year the responsibility to conduct a farmer survey. And so if we don't remember it, so that's all this is, just basically what we learn. I try and just pull out the major points from all of our relevant speakers. And then our farmer survey this year was in 2 parts. So the first part was way back in March. I know I have trouble remembering what happened, but so basically there was a virtual ag pesticide applicator meeting run by Sarah Kingsley Richards through UVM. And so we asked her to do our survey questions as a poll during the meeting, and actually was probably one of our most successful participatory surveys. So we got 55 responses. And so we asked them basically what environmental impacts are of concern when you're using agricultural inputs. And the most people said, in addition to non-target pollinator exposure, which has been our focus for the last 2 years. But also disposal, the next most common thing is disposal of farm materials that are no longer useful. So basically disposal of ag waste. Lower on that list, but still chosen by some participants, were microplastics and PFAS and non-target rodenticide exposure. So the second question is around what challenges do you face to reduce ag inputs that cause you environmental concern? And so most respondents said, yeah, it's the effectiveness or availability of alternatives. And then followed by the cost and knowledge of those alternatives. So the second round of this survey is we also had those 2 questions, and we had planned to include them in a wider survey that Margaret Skinner and Cheryl Frank Sullivan were planning on disseminating to high tunnel growers, kind of in the whole New England region. And so it turns out that they didn't start that survey until pretty late in the year. So we got some very preliminary results before this report was due, and I'll share those with you now. So we got them after we met in early December, but the goal for that survey for Margaret and Cheryl is to really push it at the upcoming meeting. So we probably will have more responses from Vermont farmers in the next month or 2. And so we asked those same questions, and so this is what Cheryl sent as just really preliminary results. So they had 30 responses in total, but only 5 were from Vermont. So you can see kind of this breakdown. So they had just New Hampshire, Maine, Mass, and New York represented as well. Because we need to show what counties people are from, we asked them to include this question of, if you're from Vermont, what county are you farming in? And so we only kind of reached 3 counties so far with these questions. Oh no, 4 counties. And so here's that first question. And so they can pick, more than one. So all 5 said disposal of farm materials that are no longer in use. And then followed by all 4 of the 5 picked microplastics. And so this was the first time that that's kind of risen to the top for us as an environmental impact. And then a smattering there of the PFAS and non-target pollinator exposure, non-target rodenticide exposure, and other one person listed introduction of new weeds and pests from bringing in off-farm inputs. So challenges faced, a lot of availability of alternatives is lacking, and then followed by lack of knowledge of available alternatives. And then you can see the cost and efficiency of those alternatives. So more to come on this. So we'll probably reach back out to them for more thorough results when they close the survey, which would be in a month or 2. But so we summarize those results in our survey, in our summary report. And so because of that, we have a list, sorry for the scroll, of kind of planned focus areas for this year. So for calendar year 25. So obviously these aren't really listed in priority order, but we have the responsibility to continue and help and consult with the Agency of Ag for the finalization of the best management rule for neonic treated seeds and neonic pesticides. But in addition to that, I think based on those survey results, I added in recommendations of reducing and using waste associated with plastic, which has been listed as a charge of AIB when it was formed. and also maybe looking into some historic recommendations by other groups about pesticide reduction. That's always been in our responsibility list, but also agricultural waste disposal. So there's been some historic programs within the Agency of Ag, but then we're learning about some new programs that we're hoping to hear about probably in the next meeting, hopefully, that are kind of developing in Vermont about ag waste. So that is on our list to do based on what farmers are responding in that survey. And I think that's all I wanted to call out for that. Annual report. Did any member have anything to say or comment on for the annual report?
Has that been posted to the website? I don't think.
So it might not be on the AIB website. I'll put it on today.
On reports, right.
But it's on the legislative reports website. Yeah. I do see Steve, you've joined. Steve Schubart. We want to just give a quick introduction because I see you now. I missed you.
Yes, Steve Schubart, board member, representing beef and meat. Sorry I'm late, out on the farm today.
Yeah, and Steve, if you missed it, we have a new member, Leon Course, representing organic growers.
Hi, Steve. I think we've met before.
Hi, Leon. I think we have. Great. Glad to be working with you again.
Thank you.
Okay.
Thanks, Steve. Okay, the next update that I wanted to give in this section is, as long as we're talking about our 2025 AIB, what does it look like? We wanted to propose, so we have been really hitting the meetings the last 2 years, really, because we had this legislative charge as a responsibility in 2025, depending on if something comes down the pipe with the legislative session going on, I'd like to propose meeting every other month. So trying to maintain the fourth Monday of every month, but going to every other, that would mean that we are proposing to meet March 24th. And then May, we have Memorial Day, so we kick it up a week. So it'd be May 19th, and then July 28th, September 22nd, and then December, kind of that early December. So that you're not hitting the November, you're kind of splitting the holidays. So similar timing that we did this past year. So I'd like to hear if any members would have any comments on that meeting schedule. We're definitely cognizant of your time and efforts and really appreciate all of your input. And we've been asking a lot of you the last 2 years, so we wanted to alleviate it some by going to every other month. So if any members want to chime in on that meeting schedule proposal for 2025. Is anyone opposed to meeting every other month for 2025?
Seems like everyone's okay with it.
Okay, I'm gonna go with every other month in 2025. So what, just logistically, I probably will start fresh with a meeting invite for 2025. So this series will get canceled. And so we'll start fresh. You'll see a new meeting invite come through. And that information will still be posted on the website. For anyone else who wants to join, you're more than welcome. And so thank you. Okay, so Heather, I did see you join as well. I skipped your introduction, but why don't we just hand the floor over to you?
Okay, great. Thank you. I'm gonna share my screen. Okay. Sorry. With that, can you see my full screen?
We're seeing
Yes, but we
notes.
also see like the table of contents. There you go.
Oh, was it okay before? I don't know what I'm doing.
No, the
Let's
second
try
one
that.
was better. What you just said. Yeah, that's
it.
Okay, great. All right. Well, today what I was planning to do is provide an update on the work that our team at UVM Extension has been doing on the topic of neonicotinoids, assessing risk of the pests that cause early season damage to corn and soybean stands, and also some of the work we've been doing on possible alternatives to neonicotinoids over the last year. I just want people to keep in mind, we're still summarizing this data. This is very preliminary. It does take a lot of time to get all of this together and do thoughtful analysis. And so we're still working on it, but wanted to show you what we've put together so far. All right. So just to review why people are using seed treatments. Seed treatments have been used historically in Vermont to manage early season pests and diseases. We live in an environment that has historically had very cool springs, often also very wet, generally slow to get going, and that can predispose seed to a whole variety of pests once it's put in the ground. Now we do know, and the literature shows over the years, that yield responses and economic returns from seed treatment use can vary. And that's not just in corn and soybeans. That includes a whole host of other crops as well, vegetable crops, potatoes, etc. So it does vary. A lot of that has to do with the type of crop, the weather conditions, field history, and a whole slew of other kind of factors that would influence whether or not we would see a major outbreak of these pests. I will note that these are common pests. They're around, they're always around. But whether or not they're going to cause economic damage to a field is, I would say, an unknown. And I feel like we're unknowing more and more and more through the work that we're doing here, evaluating these pests. So there's a whole variety of seed treatments that can come on seed, and these range from fungicides, which are very, very common. Those have been used for a very long time in this state and beyond. There's insect protection now in the form of seed treatment. There's various inoculants that can go on the seed. There's all kinds of biologicals. There's the different binders that are used and the dyes. I mean, most of the seed that is being planted looks pink, looks purple, looks green, all kinds of beautiful colors. And most of those colors are on that seed so that the seed is very visually different and doesn't enter the food chain. But there's lots of things going on seed these days. And, it's a lot to keep track of for people. Sometimes seed comes treated with a whole variety of things and people don't even know, honestly, for the most part. So it's complicated. I would say two of the most common here in Vermont are insecticides and fungicides, the binders and the dyes. I would say those for most of the seed coming into the state, the majority, especially corn, have seed treatment, with soybeans being less so. Okay, why is that not moving? Let's go. There we go. All right. So when we talked last year, I was telling you that we were going to be starting to look at planter dust. So one of the questions that often comes up is if this insecticide is on the seed and the seed is going into the ground, how are the neonics getting out of the ground? And there's been, a body of literature, primarily from 2015 to 2017 that showed that the dust that was coming out of planters or being generated by planters contained some of the insecticide and likely some of the fungicide as well. And so here's a picture of planting during dry conditions in the spring. So you can see all the dust forming. And so, you could possibly see how neonicotinoids might be kind of getting kicked up into the dust, either from the soil surface or possibly out of the planter itself. So again, there's been a good amount of work done on this. There hasn't really been much recent work. So most of the work that was done through the Corn Dust Consortium. And again, like I said, between, this says 2014, but 2014 to 2017. And then there was a big report posted through this Corn Dust Consortium, and that's available online if anybody wants to look that up. But, what they found was that the seed treatment itself, the integrity of it wasn't very good, and that it was actually kind of getting chipped off in the planters and during planting. And so you can see the pictures in the photograph here, and you can see if you're seeing yellow, that means it used to be covered by seed treatment, and now that seed treatment is gone. So the seed treatment wasn't sticking onto the seed very well, and it was coming off and making its way out into the planter dust. So this was shown a number of years ago. This was well known by various seed companies. And, there was purported work done that the seed treatments were better, placed on the seed. Remember I said there were these binders, so maybe the binders improved, but nobody has really looked at this since. And if the binders have been approved and the seed treatment isn't coming off the seed, that's great. But again, we don't have any evidence to really show that at this time. So we worked to repeat two of the studies that were conducted with the Seed Dust Consortium. And one was essentially collecting dust that was moving off of the fields during planting. So we put into place the same exact process they used. And you can see to the left here, these are these dust towers. It's a metal pole, and you can see that colorful blue rectangle on the top, and you can see one down below. And these are the dust collection units. And what that is actually is a bunch of microscope slides slid into like these little clips, and then they're covered with tanglefoot to catch dust. And there's some near the soil surface, and then there's some up in the air. And so you can see the schematic to the right where we place the dust collection units. downwind during planting. And the dust collection units were, roughly 82 feet apart along the edge of the field. And we also had one dust collection unit under the planter or right next to the planter when it was going by to see what was coming down onto the surface of the ground. So we went out to a number of different sites. Oh, sorry, that's kind of cut off there. And we tested, or we went out to a number of different sites last spring, so the spring of 2024. And we measured, the wind speed at the time of planting, the direction, the humidity, the temperature. We also looked at soil moisture, soil type. We looked at the fluency agents being used on the farm. We looked at other practices too, if it was no-till, if it, excuse me, if it was tilled. And then we put out the dust collection units and we planted, and then we waited several hours and then went out and picked up the slide trays. Sorry, they were then sent in to Vail to analyze them for neonicotinoids. So you can see the different soil types here. So I will say it was a very wet spring. So there wasn't a lot of dust at all. It was very, very wet, if anybody remembers. It was very difficult to get planted. You can see most of the fields, more than half the fields we went to were actually on sandier soils because it was so wet, people weren't able to get out and plant. So it was a really challenging year to do this. Again, the wind speed when we were planting was very low, and the soil moisture was actually really high. So not good conditions to create dust. So this is the data that we got back from the lab, and the detectable limit here is 0.43 nanograms per centimeter squared. So a very, very low amount can be measured. And you can see the different sites to the left: Highgate, Swanton, St. Albans, Franklin, Middlebury. Then you can see the collection height. So on the ground, 30 centimeters to 100 centimeters. And then you can see the measurements from those slides. So again, because of the conditions last year, at least that's our hypothesis, we actually we didn't pick up any detectable levels of neonics on the edge of field, except for at one spot in Middlebury, where we did pick up 0.7 nanograms per centimeter squared at the soil surface. So we're going to do this study again this year, and look at another year and see what we find.
Got a question
All
from
right.
Steve Schubert.
Yep.
Thanks, Heather. This is so fascinating.
Yeah.
Back on that schematic, I'm looking at the wind direction. How far is that, or how is the distance determined with where the tractor's in the field in relation to the dust collection devices?
Yeah,
Does
so
that change
the
or
dust
sway the data,
collection
or
was
did I
at
miss
the
that?
edge of the dust collection was at the edge of the field. And so we started planting at the edge and moved our way out 400 to 500 feet. So we planted continuously. Yep. So we all started, closest to the dust collection units and then moved our way away. And it was on the downwind side. But again, I mean, this wasn't a year for dust. I mean, it was so wet.
Right.
It was very difficult. And really, there was not much wind either.
Right.
Yeah.
Do you
All
think
the
if it was a
corn
dusty
mostly
year,
went in the ground. What's that?
Do you think
Go
if it
ahead.
was a windier or dustier year, it may be, the data may be different?
Yeah, and I'll show you some information about that. So,
I'm putting the cart before the horse, sorry.
yeah, a little bit. Yeah. Probably should have showed the other stuff first, but
Hey,
Steve, you had
Heather, I
a
got-
question?
Yeah, I'm just curious, in the work from the Corn Dust Consortium, did they have any information on correlation with humidity or soil moisture or wind speed or anything like that?
I don't particularly remember that, Steve, but you know, I think they had seven farms a year, different planters, different conditions, and they definitely picked up neonics in those dust collection units. So we were obviously surprised we didn't see anything. But again, I'll show you some data that makes us realize, like, yes, there's dust coming out of planters. So yeah, so the next study that we repeated that was done by the Dust Consortium was to directly catch the dust that was coming out of planters. So, you know, that study I just showed you was being used to measure like off target movement of neonics. And this particular study was to look at, you know, what's actually coming out of planters. And we repeated this study as the Dust Consortium did, but, you know, we did have one modification that I'll talk about in a minute. So you can see these white bags, that's a vacuum bag. And that was placed over the planter exhaust. And we collected all the material, all the dust and everything else that would come out of that exhaust normally, but except we were collecting it into this bag. We did this experiment to look at seed type and also seed fluency agents. So many farmers will use a fluency agent when they're planting to help the seed flow through the planter, help get a more uniform seed population. And that's, I mean, it's still fairly standard with new technology and precision planters. People are going away from using fluency agents, but it's still pretty common throughout Vermont. And you know what the Dust Consortium showed was that some fluency agents chipped the seed treatment off more than others. They were more abrasive. And there are some alternative fluency agents that there hasn't been a lot of work done on that may be less abrasive. So if the problem here is that these fluency agents are kind of chipping away at the seed treatment, and then that seed treatment becomes loose in the planter, and then gets blown out of the planter through the exhaust. You know, is there a way to kind of really minimize that? And again, the Dust Consortium did quite a bit of work on this. It was actually largely inconclusive. There wasn't a strong recommendation one way or the other. They couldn't really you know, see a planter that was necessarily better than another one. Some were far worse. Some of the fluency agents, just the results were pretty variable. But again, the thought is that the binding agents that bind the seed treatment onto the seed have improved, right? People knew this was a problem. It was well identified and documented. And so there was, you know, people saying that the seed treatment had gotten better as far as it being stuck on the seed. So we wanted to evaluate that again because it hasn't been looked at. Now, the modification to the study for us, you can see at the bottom of this bag, you can see kind of that colored thing showing through. And unfortunately, we didn't have the capabilities that this other lab had to be able to essentially clean all the material out of this vacuum bag. So what we ended up doing was putting the slides like we did in the previous experiment in the bag, in the bottom of the bag, and we sprayed those with Tanglefoot. And then we measured what we got on those slides. So, the quantities are probably skewed a little bit because has a Tanglefoot on there. It's going to get a lot is going to get stuck right on those slides. But I think, what we found was there's material coming off the seed. So I'll show you that next. All right, so we looked at these 4 different fluency agents. We looked at graphite and talc. Those are the 2 most common fluency agents. Graphite in particular is thought to be very abrasive. And then there were these 2 alternatives that we looked at that are on the market. One is called Dust, which is a soybean-based product, and the other one is from Bayer Fluency Agent, and it's a polyethylene wax-based, fluency agent. You can see the Dust product, how cakey it was. It definitely would pose significant issues for producers using that, especially with our high humidity here. It didn't want to go on the seed very well. It just became sort of a cakey mess. So that one probably wouldn't fly here anyway, but the Bayer Fluency Agent was easy to apply, and that seemed like it could definitely be a good alternative. All right. So we didn't see much difference between the levels of clethiodin getting onto that slide set and the fluency agents. We did see the graphite was a bit higher than the others, and you can see the Bayer was a bit lower, but nothing really conclusive in regard to the fluency agent itself. And again, you can see these levels they appear to be very high, which they are. I mean, that's what was on that slide set. Most researchers would extrapolate this out to grams per acre or hectare, which we haven't really had time to do yet. And we have to figure out how our modification kind of influences that calculation. So, the real take-home message here is that there's neonics coming off the seed and making their way out of the planter exhaust. So now what was really...
This is Nate North.
Oh, go
I have
ahead.
a question.
Yeah.
I can't see the data charts. What was the date that the time of the date that you were looking at this?
So we were planting this project we did in August. So we were running our planter. So what we did was we had 2 different seed brands and we had 5 different fluency agents. So for each seed brand, we would have no fluency agent, and then we would have it with talc, dust, graphite, or Bayer. And we would go out with the commercial planter, which you saw, and we'd go out and we'd plant with the planter, about 400 feet. We did that 4 times, collected the dust each time, and then we would thoroughly clean out the planter to do the next treatment. We always started with no fluency, so that we didn't risk any contamination. But
in general, wouldn't most of dairy farmers be planting sometime in May?
Yes, but this is not Oh, go ahead.
And if they were planting in May, would there be that many, let's say, pollinators out even? Would there be flowers around the field?
There could be, especially dandelions, the very early flowering dandelions. Yes.
And that would be what, maybe towards the end of May in Vermont?
Yeah, probably.
And then when we're spraying berries and trying to keep the bees safe, we usually do it at night. If the application was done at night when the pollinators aren't around, how would that affect them?
I don't really know. We're not looking at where the neonics are landing. We're not sampling plants around the field at planting. The study where we're looking at movement to see if the dust was moving off of the field, that was done in May during normal planting time. This was really done just to see what was directly coming out of the planter.
Because even in your best spray scenario, there's always going to be some fraction of drift.
In your what material? I'm sorry.
In your best spray conditions with a boom sprayer or any type of sprayer, look at an orchard sprayer even. There's going to be some drift, and
yes, absolutely. And
this
is why this is in question, because this seed is going in the ground. They're not spraying anything, and so the real question came up is, well, how is this getting off of the fields? That was, the initial question. And that work was done, now a decade ago. And now, now the question is, well, is the seed treatment better? And is it sticking on the seed better? And really what we found was it's still coming off the seed. So here's the seed brand. So red is one brand of seed, and green is the other brand. Both of these seed brands, to remain nameless at this point, had the same exact seed treatment. They had Lumigen at the 1250 rate. Okay. So when you look at untreated, that means that they didn't have any fluency agent on them. And there was still dust coming, there was still seed treatment coming off of them. The red brand seemed to have more coming off of it than the green brand. Now, when we looked at, go ahead.
So when you talk about all this dust, the way that I recognize corn is handled, it's kind of dusty in itself. There's a dust component, whether it's neonic or not. There's a lot of regular dust in those things. It just isn't washed seed or anything like that. How could you determine that it was just regular corn dust coming off?
This is right out of the planter. It's not any other dust. We weren't like collecting dust from the field. This is just what was coming out of the planter.
No, but inherently speaking, the way they mechanically handle all this corn seed, there's going to be a dust factor in itself that is not associated with the chemical, just in the way they handle stuff.
But when the chemical might come out of the planter and it gets up into the dust itself, it can move off of the field. And that's what we were trying to understand, how much is that? Is it happening? Is the seed treatment on there more solid so that it's not coming off? And we didn't have any real dust this year during planting, like normal planting dust coming up off of the fields as you're talking about. And we didn't see any movement of neonic. We also didn't have much much wind either.
So how would
So
the dust in the field contribute to the neonic going any further? I mean, if the neonic, if the field is wet, like you said, or whatever, and the dust blowing across the field that's hitting your trap, you're not finding much neonic. It seems to me it's very low, if at all, if anything at all.
yeah, we didn't find any this year. That's what I already said. And now we're collecting the material that is coming out of the exhaust of the planter, which would theoretically be coming out of the planter. But we were capturing it. We weren't letting it come out of the planter. And I think the take-home message here, so let's just get through that, is that there is a difference in how the seed coating is stuck on these different brands of seed. So if you look at the graphite in particular, you can see how abrasive that was to the one brand of seed, but not to the other, which really to me is showing that the green brand, the seed treatment is stuck on better. Far less of it is coming off. I mean, significantly less. And so then when you look at this Bayer fluency agent, you can see regardless of the seed, it really suppressed what was coming out of that planter. I mean, these are very, 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 they're very small amounts. And again, this is on those slides. And now if you extrapolated that out to how many grams per hectare or pounds per acre, it's a very small amount that's coming out. And so using a practice like applying this Bayer fluency agent could really further suppress any loss that we have. And that, that's a goal regardless of the seed treatment that you have. So that particular fluency agent seemed to really make a difference regardless of the seed brand, but it did seem that the brands of seed really differed in how well they were kind of stuck onto the seed. And, that's a really important piece of this to recognize that we could have far less risk if the seed treatment is applied in a manner where it's not going to come off. And if we're using a product like Bayer, possibly, it could be even less. So I think that's really what we found here. That was, to me, it's exciting to know that we can minimize risk quite considerably.
Did you guys
I don't know
measure
how the material is being bound to
the
the
amount
seed.
of fungicide in the trap?
We didn't track fungicide, no, just the neonics.
So is there a possibility that, how would you know that most of the dust wasn't the fungicide dust? I've handled a lot of corn seed that can be pretty dusty with that stuff.
We were just analyzing for neonics. So, I mean, there definitely possibly could have been fungicides in there as well as, soil particles, but those get separated out. The concern here is the neonic. This isn't total dust that we're measuring. This is actual neonic that was collected from the dust.
Thank you for your responses.
Yeah, no problem. Okay, so our plan is to, repeat this again this year. There's a lot to unpack here. It's complicated. We used one planter. It definitely could be different between planters. We only looked at 2 seed brands. There's many, but I do think these are really important risk management. Sorry, my dog's whining. Risk management practices that could be put into place. So we've also been looking at neonicotinoids entering surface water from surface runoff. and also coming out of tiles. So we talked about this last year. We're going into our 3rd year of monitoring neonicotinoids coming out of tile and coming off the surface of the ground, surface of the soil. This is that one site. It's at a site in St. Albans Bay. It's on a very heavy clay soil. We're looking at a whole number of water quality parameters here. These are big research plots. These are, you know, 3 to 6 acres each. And there are 2 tiled kind of watersheds and 2 watersheds that do not have tile. And then at the edge, there's edge of field collection sites where we can collect surface runoff and we can collect water coming out of the tile. So again, we're looking at neonicotinoid movement in the surface and subsurface water. And then we're also looking at soil persistence and movement. Okay, so here's where that site is. You're all Vermonters, so you know where St. Albans Bay is. It's in a heavily impaired watershed up in northern Vermont. It's on the Jewett Brook watershed to be exact. And again, it's all Covington clay soil there. The experiment was, again, put into place really to look at phosphorus and nitrogen losses, primarily with different management practices. So the management practices we're looking at to reduce nutrient losses are cover cropping and manure injection, no tillage, and rotation. Okay, so here's just a little bit of a closer view. So you can see there's collection points, those purple and striped collection points. 2 are the tile stations where we're collecting water coming out of tile, and 4 are surface collection stations where we're collecting surface runoff as well. These are the different best management practices that are being used here as well. So last year we looked at clethiodin in particular. That's the that was the seed treatment used, and we looked at neonics coming out of tile and also those present in the surface runoff. These were the primary collection points. This isn't loading, this is just concentration, but you can see that once we started to get heavy rainfall, and again, this is 2023, we saw a flush of neonicotinoids out of both the tile and off of the surface. Okay, so that's when we saw our highest amounts. And then those amounts went way down after that. And actually we didn't have any detectable levels past October. So we did this again this year. It was overall a drier year. Last 2023, I think we had 100 samples collected. And 2024, we had about half that because there was less rain, right? We can only collect samples if there's surface runoff. So you would have enough water essentially that would run off the surface of the field, or if water was draining and coming out of the tiles. So we collected 29 samples from tile and 25 from surface. And of those, we had 14 of those samples that had detectable levels of neonics. And off the surface, we had 7 samples that had detectable levels of neonics. So about half of the samples from tile and about a third from surface. So this only represents through August. After August, you know, it was very, very dry. So we haven't really had much of any sampling since then. So this just shows the data that's been collected and from what site. And again, this is concentrations of clothianidin. So you can see we didn't really have any detectable levels until the 7th of June. And usually what we see if we get a significant rain event following planting is that we'll see this kind of flush of neonicotinoids that move out of the soil at that time, and then the levels drop considerably from that point. So where there isn't any data being reported, so you can see there's nothing here. If you go down 11th of July, 30th of June, etc., there's just no water to collect. So we don't have any runoff and we don't have anything coming out of the tiles. So again, this is just concentrations. It's not volume. So just, keep that in mind. But it's similar to what we saw last year. And again, we haven't had much sampling at all since this time. So we're also looking at neonics in the soil. So at this site in St. Albans Bay, this 2024 was its 4th year of corn. So this field is in an alfalfa corn rotation. So it was in its 4th year of corn. And each year the corn has been treated with neonicotinoid. So the first time we sampled for neonicotinoids was in the spring of 2023. And we found detectable levels in 88% of the samples in the top 2.5 inches of the soil. So we didn't find it everywhere, but in the top 2.5 inches, 88% of the samples that we took had detectable levels. And less than half of the samples had detectable levels 2.5 to 6 inches. So we went out this year in 2024 and did the same sampling. And interestingly, you can see this spring, we had less detectable samples. So I'm assuming possibly this was because of the significant rainfall we had in 2023, but it's hard to say. But we definitely had less samples in the surface in the 2.5 to 6 inches that had detectable levels of neonics. The quantities are, about the same, but the number of samples was far less. We sample at the end of the year as well. So in 2023, we sampled on the 3rd of November, and then in 2024, we sampled on the 30th of October. And at the end of the season, much higher percentage of the samples have neonics present. And, that was consistent both years. So there is residue remaining in the fields year to year. We had another site that some of you probably remember that was in Alberg. And at that site, we went into an area that we thought had been free of neonicotinoids for some time. And that's why we went into that site and we planted neonicotinoid treated seed, and we wanted to monitor the degradation of neonics over time with just 1 year only of treated seed. So in May of 2023, you can see that we did still find, even though we didn't think we would, we did find neonicotinoids in the 2.5 to 6 inch range out in this field. We didn't find any detectable levels in the surface. And then we monitored those levels throughout 2023. And then again in the spring of 2024. And you can see a year later, roughly, there were no detectable levels in any of our samples for neonicotinoids. So it does seem that possibly if we're using neonicotinoids periodically, there would be hopefully enough time, depending on the soil, of course, and the weather, for the neonics to degrade. But I think there's a lot of factors at play here. The other site is heavy clay, and this one is more of a loamy, fine textured soil. So some pretty significant differences there. All right, so probably running out of time, but I wanted to talk again about why we use seed treatment, what makes our conditions here in Vermont conducive for some of these pests. We hear a lot from some of the other regions that you know, these aren't real issues. And you know, we shouldn't be worrying about them. They're secondary pests, but you know, they are issues in Vermont. They can be quite serious issues. I've seen it throughout the 20 some odd years I've been here. The most recent I saw in 2023. I showed this slide last year. We had complete devastation of several hay fields around the state from grubs and wireworm buildup. And I've seen corn crops decimated from seed corn maggot and wireworm. So it does happen. I think really what we're trying to understand is, you know, what puts us at risk? Can we predict when it's going to happen? And really try to figure out, you know, the risk factors here. So, you know, I'm probably running out of time, but
you're okay with time, Heather. Don't worry.
Oh, okay. All right. Okay. So seed corn maggot is probably the pest, at least in corn and soybeans, that people are most worried about. They're not really pests of corn or soybean. You know, they're looking for their flies, their maggots. They're looking for decaying dead things. They're opportunists, and you know, they happen to infest the field. They can start, you know, laying eggs and sort of attacking corn and soybean fields. We know that injury seems especially prevalent during cold and wet springs, which we've traditionally had a lot of, and when plants are growing slowly. So, you know, the warmer the ground is, the faster the plant germinates and gets out of the ground, the less risk there is. But we also know that that's not very common in Vermont, especially around the time when we're trying to plant corn. And so just by nature of, you know, our environment, we are at more risk for damage. All right, we talked about this. There are, you know, there's not very much real literature out there. It's very limited, but there's a lot of talk and a lot of articles about high organic matter fields, decaying plant matter, decaying manure, put those fields at high risk for this pest. Because again, it's, you know, it's a fly, it's a maggot. There's some kind of sensory cue there. And so there are a few papers, they're quite old actually at this point, from the 90s, before seed treatment was even on the seed. It looked at cover crops and tillage, and how that impacted seed corn maggot. All right. So we wanted to, sorry, we're having trouble with our dog. Pissing me off. So we had a trial that we put in this year where we looked at tilled and no tillage. We looked at manure broadcasted with tillage, injected manure, cover crops, tilled and no-tilled, a whole combination of practices that are common in Vermont. Sorry, can you excuse me for 1 second?
Go ahead, that's fine. I will just while she's gone, I did see, I think Amanda may have had to jump off, but I do see her question in the chat, and we can try and dig into that. I know Heather might not have the answer to this either. So the question in the chat, are they doing now any in-field research of the health of hives by cornfields based on neonic and testing and comparing to hives by cornfields without neonics managed by beekeepers the same way? So we can look into that. I know that we're aware. Yeah, go ahead, Stephen.
Well, Brooke, are you still on?
Yep, I'm on.
Yeah, so we have a ongoing study, which is not directly addressing that question, but we are looking at, we have a long-term study on health of hives, the 3036 study. And Brooke, you might just briefly mention it. And we can always come back and give a report to the board on it.
Yeah, so just to fill some time, so we have 6 sites throughout the state, and this is 3036 is the number referencing the statute. So it's under the apiary statute, and 3036 is the number. I forget the first 3 numbers, but Heather is back, so we can report on it if folks are interested in hearing more about that survey.
Yeah, we will. We'll put that on the agenda.
Yeah, Brooke, why don't we can just do it on a future, maybe March.
Yeah, March, because if it's May, I'm gonna be insane. So,
yeah,
earlier.
We'll
than
do it
later.
in March.
Yeah, perfect.
Okay.
Okay.
Great. Thanks. Go ahead, Heather.
Sorry. Yeah, sorry about that, you guys. We've got sick kids, sick people, and a dog that's super ornery, barking at everybody. Apparently, I'm the only one that can handle it. Okay, that's great. Okay, so we really wanted to look at how the practices that we use today impact the risk of seed corn maggot. So we do have a lot of farms that are transitioning to no-till, but we also have a lot of farms that are adopting cover cropping and also manure injection. We still have a lot of farms that till fields. So really trying to start to understand if any of these practices put our fields at more risk than others. And so you can see all the combinations that we looked at. Cover crops, again, no-till, tilled, with manure, without, injected manure, etc. So you can see that the results were highly variable. So this is the percent of seed corn maggot, seed damage, and you can see all the variation in the treatments. It was really hard to pick up some differences here. And we did plant very early. It was cold and wet conditions, and but still just a lot of variation around this. So what we did was we worked with a statistician here at UVM to understand the percent probability of having damage. So we looked at the statistics a different way. And so what we did end up seeing is that your probability, your risk to damage from seed corn maggot goes up quite substantially if you're tilling or you're adding manure. So no-till systems with no manure at all were the lowest, your kind of lowest probability of damage. And when you add tillage in or you add manure in, the probability of damage goes way up. It, more than doubles in most cases. So we do know that those fields are at more risk, and we're going to continue to look at this, into the coming years. We didn't see any differences with cover crops, though. And I know other people have seen differences or have seen differences with cover crops. So we're going to continue to look at this. This is just 1 year of data. Again, trying to understand risk here. I see somebody had a question. I don't know if we want to take that now.
Hey, Heather, this is Emily. Thank you for presenting on this. This is really great. I was just curious on this part, if you were looking at the amount of time from the treatment to the planting, like from tillage or manure to the time of planting.
Yeah, it was within a week.
Okay, got it. Thanks.
And again, it was really based on conditions, right? So we had a tough season to try to get anything done. Sean, I see you have a question.
Your kids and dogs make me feel better about mine, first of all. But I've been there. Any idea why the tillage has an effect? Do you think it's an aeration effect or heating versus cooling?
No, I think again, it's that decomposition, you know,
Speeding
that
up the
smell.
decomposition when you
Yeah.
till. Yeah, okay.
You know, there's various literature here and there, you know, like those Hammond papers that talk about, you know, plowing under green manures and just, you know, they found, and I think Emily, maybe this is what you were getting at too. You know, they found if you waited several weeks, and this is like the old recommendation anyway, if you plow under a lot of lush green material, you should wait 2 to 3 weeks before you plant. But you know, I think we all know that's not normally, might be an option, might not be.
Thanks.
Yeah. I don't know if you want to
Ross?
take one of, yeah.
Yeah, sure, we can. Go ahead, Ross.
Yeah, not to interrupt the rest of the presentation here. But yeah, I was wanted to just mention I've heard from several farmers this past year wanting to be really cautious about cover crops because they're making the assumption that cover crops without neonics is going to cause more problems and crop loss. So I just was hoping, and this is not a conversation for right now, I don't think, but for later, and maybe at the conference here in a couple of weeks, cover crop conference, can be a discussion of just kind of getting ahead of those conceptions and what we know about this and letting the farms know. So all of a sudden we're not losing a lot of the progress that we've made over the years with more cover crops and then all the data related to loading and whatnot. And then, you know, I've seen some other articles talking about how cover crops are more effective than insecticides are for managing pests and whatnot. So hopefully we can get ahead of it a little bit with
Yeah, I mean, it depends. I think it's really depends also on the cover crop, and some people have shown that. I mean, majority of the cover crops here are, if they're left to get large, they're no-till systems, which we find not to be very conducive. And mostly what we have is grass, and that doesn't seem to be as attractive. So I think there's a lot to learn. Cornell's done a similar study, and they also haven't seen an effect of cover crops either. So, but we got to keep monitoring. So, so there's a lot of talk about using growing degree calculators, monitoring flights, looking at risk. I just went to the Cornell meeting last week or 2 weeks ago, and you know, basically where we're at right now is that just because we have a peak flight doesn't mean we're going to see damage, and the flies are out there early. There's just not enough predictability just looking at growing degree days and flights to determine if they'll be damaged. So both of our teams are looking at other factors, some of those I just mentioned. And so it seems like less of an option at this time. Not that it's not important to monitor flights and if there'll be damage, but it still seems pretty not predictable. We have been looking at like planting corn across a really wide window to see if we can get damage, and monitoring flights, and we really haven't picked up anything either, even when we plant on peak flights. So, you know, here's the data from this year. You can see we planted the 4th of May. I mean, completely horrible conditions to plant in, cold and wet. And we planted to the 8th of June. That blue bar that goes up and down, you know, those are the seed corn maggot adult counts. So you can see where there's some peaks there, where it goes kind of up and down. We have a big peak in June. You know, theoretically, all the corn would be planted by that time. It'd be warmer. But even when we planted in the 4th of May, you know, we did see significant differences between treated and not treated seed, but we had higher corn populations in the not treated seed. And we saw some of these same things last year, where mostly we didn't see any difference between treated and not treated, regardless of the planting date. What you should note here, which is interesting, is that, you know, we're planting at 34,000 seeds per acre, and we're losing, you know, about 9 to 10,000 plants per acre in those counts. And that's not to it's not to seed corn maggot. So, you know, there's other things happening out there. The conditions are not good. Regardless of seed treatment, we're losing plants. So we've got a lot more work to do, really, to understand, again, risk. When do we see these outbreaks? Quickly, I want to talk about the work we've been doing, looking at diamides, which is considered the alternative to neonicotinoids. There's already companies that are treating with diamides. It's already an option for farmers at this point. They are more expensive to produce, quite a bit more expensive than neonicotinoids. So certainly the cost of that seed treatment would be higher. Supposedly they have a lower toxicity to non-target insects, and they're not as water soluble. So there's some benefits, definitely, it seems, to using diamides over neonicotinoids, and we looked at that this year, as well as looking at spinosad, which would be an organic alternative. So this is corn seed. You can see there's a control on the top with BM, that's bone meal. So we kind of artificially added organic matter, decomposing manure basically, or bone meal. And then we have a control. So the control is just untreated seed. So both of these, control with bone meal, control without it, it's completely untreated seed. Then we had a fungicide treatment, so fungicide only. Then we had fungicide and diamides, fungicide and neonics, and fungicide and spinosad. So you can see the amount of seed damage that we saw when there wasn't any seed treatment. And it was quite significant. And again, we planted May 7th, I think. I mean, really early, very poor conditions, trying to get damage. When we added a fungicide, you know, we reduced the amount of seed that was damaged, right, quite considerably, by about half. When we added an insecticide on top of that, we reduced it again by half. So, you know, in this year, having both any of these insecticide treatments and the fungicide, we saw far less damaged seed. Still a lot, 25% is a lot, but it's better than half or 3/4. So, you know, they do produce more healthy plants when you're using them under these adverse conditions. Now, the interesting thing here is that we did look at corn population. So how this was done, and Cornell and we did the same exact experiment. We planted 2 rows of corn, 20 feet long, 6 replications, with the different seed treatments, right? And then we counted the populations in one row, and then the other row, we dug up every single seed. We knew how many seeds we put out there, and we dug up every seed. And then we evaluated it for damage. So we planted at 36,000 plants per acre, and you can see the reduction in plant stands without any seed treatment. And it was quite substantial, but the yield reductions were still substantial, even with seed treatment in a poor year. Unfortunately, this study was not taken to yield. That would have been very interesting. It wasn't the methodology, and because you're destructively sampling all of these things, there's no real way to do that. We did the same thing in soybeans, very different story in soybeans. Soybeans are generally planted later. We planted these, I think it was about the middle, 3rd week of May, actually. You can see the control with bone meal. We had the most damage. But then the others, either a control or with fungicide or neonics, we had very little damage, not like the corn. And the populations didn't really vary. And this, this was, I don't know, we had to dig up 180 seeds or something, and look at all this. So I'll end on that. We're going to repeat this study again. All the studies are being repeated, actually, and then we're going to expand our on-farm sites. I don't have last year's on-farm data completed yet, so I didn't show it, but we will be expanding the on-farm sites. So I will stop sharing, and yeah.
Thank you, Heather. That was awesome. Great data download. And thank you everyone for asking questions as she went along. I do see that there's more in the chat as far as just information sharing. So I will include the chat within the transcript. That always is the case. If things are shared in the chat, they're included in the transcript of the meeting. And then I encourage members to click on any links that were provided in the chat if they're interested. And any last questions for Heather? Go ahead, Roy.
Hey, Heather, thanks. This feels like a wonderful elaboration on what you did on Friday afternoon at the Champlain Valley Farmer Coalition panel discussion. I had one question that I'd written down here, and it goes back to the dust collection thing. Does it make a difference with the type and make of the planter that's used in there at all? Any relevance?
Yeah, I mean, it was in the earlier corn dust consortium studies, they saw some difference in planters, especially the old plate planters that were out there. A lot of people remember that. There still are some plate planters, but these vacuum planters seem to be, the ones that, they're most common today. And whether there's differences between, a White or a John Deere or a Great Plains planter, we haven't looked at that yet. But it was pretty variable in their studies. They couldn't really pick up much. What they tried to do was to filter the exhaust They tried to catch it and kind of use like a dust collection system on the planter. And it was pretty unrealistic. It didn't work. But that was the direction people were thinking. Yeah.
Go ahead, Sean.
Heather, I'm just curious what your thoughts are on spinosad as a neonic alternative, and I want to think of it in terms of, we have a lot of, I don't know how much organic corn or soybean is grown here in Vermont. I suspect it's not very much, but we have a lot of organic producers that may use spinosad on their farms, right? Are we worried about resistance in the long term if we're starting to put all that spinosad out in the environment?
Yeah, I mean, that's certainly a possibility. We know, it can already be an issue. I definitely see diamides being likely the alternative here. Like I said, most of the seed companies are already geared up. If they're selling seed in Canada, they already have an avenue to do that. There are some commercial seed producers or sales folks in the Northeast that already offer diamides. So I imagine that's likely the direction people are going to go. So yeah, I don't know. But I mentioned that we're collaborating with Cornell, and I attended their meeting a few weeks ago. Their results are very similar to ours. We're really having trouble identifying risk, like what really causes that risk, and then translates into yield loss. And we're trying to produce that, right? We've seen it. I've seen it a number of times. I've seen it on organic farms. I've seen it on conventional farms. But what are those conditions that most likely lead to that, I think is really what we're like trying to focus in on now.
Yeah, thanks.
I appreciate everyone's questions, and I know I certainly do not have all the answers. We're doing the best that we can. All this stuff takes time, and probably should have been done a while ago. It's funny, there's very little research from 1993 to 2023, basically, on this topic. So, we know why, but kind of a bummer. Yeah.
Well, thank you, Heather. As always, we really appreciate you giving us these updates, and we appreciate all the work that you're doing to help give us the answers to our questions. So thank you.
Yep, thanks.
Thanks for allowing me to have my real life on your meeting.
We all know. We get it.
So my 12-year-old walking through here swearing, I'm like, oh my God. Keeping it real.
Okay.
Yeah, okay.
Well, thanks,
thanks,
Heather.
everyone. All right.
Thank you.
Bye.
Yeah, actually, so the next thing on the agenda was just an update of where we're at with our BMP rule, and the answer to that is that it's currently under Agency of Ag kind of internal review. The draft rule that is going through that internal review is what we saw on December 9th. And then based on the comments that we got, a few of the things that we adjusted are the IPM definition is the same as what's in the pesticide rule, which is actually just good practice all around to have, the same definition across different rules. And then things are ordered, best management practices are ordered kind of in keeping in mind the IPM tenants. So they're ordered under each section so that scouting, monitoring, economic thresholds, development are first, and then alternative methods are all listed before you get to best management practices that reference to using the neonic pesticide itself or using a neonic treated seed. So it kind of aligns with IPM tenants. A lot of discussion on December 9th was kind of about the communication. So there is a best management practice that is listed in the rule about a user of a neonic treated seed should notify apiaries that have hives on the premise. Some of the discussion was around, well, they have to know, so the user of the seed has to know that a hive is on the premise. So we added a detail in that best management practice, providing that contact information is made available to the user of the seed. So that was Jonathan Chamberlain. Advice is that the owner, there's kind of might be a middleman and a break of that communication between the owner of the land and then the person who is actually farming the land, and so who is actually using the seed. So we can't have because the audience of the rule is the user of the seed. So we can't have a mandate or a recommended practice towards the apiary, the hive owner in the rule. So it's kind of, we can't just say you do this and you do this. There's only one targeted audience of the rule. So we had to just say, basically, we added a detail in there, provided that contact information is given to the user of the seed. So it tried to get at that comment that Jonathan Chamberlain had. And then there was discussion in December about aerial applications. And so we added basically saying that any aerial application needed to adhere to the pesticide rule and then any permit conditions. So any aerial application in Vermont needs to apply for and be granted an aerial permit. And then within that permit is where you can apply more specific conditions according to the situation. And so those mandatory conditions within the permit can help navigate kind of all of those nuances that we were discussing in December. And so we felt that was the best way to say, okay, well, in the best management practices, well, yeah, you need a permit anyway, so you need to adhere by permit. And the permit avenue is where we can have specific conditions. And then I think the last adjustment that we made is the Xerces recommendation had the best management practice to make sure that your equipment is calibrated and functioning properly. That was missing in our rule, and so that was added based on members' recommendation. And so what needs to happen is with that rule, once Agency of Ag is ready to go with it, we are, according to statute, we have to submit a copy of the draft rule to the Senate Committee on Agriculture and the House Committee on Agriculture, Food Resiliency, and Forestry to review. So that's in 6 VSA section 1105A. So that it says that we need to submit it to those committees 30 days before we go into filing. So that's our next step after this review. So that's kind of where we're at. Any questions or comments?
Can I say something?
Oh yeah, go ahead.
I just want to thank the board members for working on the recommendations and reviewing it and making recommendations. Really appreciate all the input on that. And there'll be lots of opportunity for input going forward when we go into the public rulemaking process and then through the legislative committee on administrative rules. There's another opportunity there. So plenty of opportunity to comment on coming up.
And the last thing that we wanted to share is that we received a public comment from kind of jointly from the American Seed Trade Association, Crop Life America, and Biotechnology Innovation Organization. Forgive me, I'm not updated on everyone who's joined us while we're presenting, but I sent that to the AIB members. Is anybody here from any of those organizations that wants to address the letter that was submitted?
Dylan Gabbert is on there.
Hello, everyone. Yeah, I'm and certainly happy to represent the group for those comments. Certainly, appreciate the work that you all are doing as the task force, and emphasize the importance of treated seed for agriculture and for our farming community. And really appreciate the emphasis on education that you guys have put forward for the BMPs that you've developed. But realistically, happy to discuss the comments or to share them more broadly. But thank you very much.
Did any AIB members have comment? I know Wendy Sue did respond. I know she's not unable to join us today, and she had no further comment on this letter, but I wanted to give the other members opportunity to comment if they wish. This will be posted on the AIB website along with our minutes and material from today's presentation. So it will be available to everybody on the call today. Are there any other members of the public who wish to make a comment? And I guess before I go to that, any other members want to bring up anything more to discuss before I move to public comment? Great. So is anybody on the call that wishes to make a comment? Great. Thank you all for joining us. Thank you, Heather, for informing us. That was great. And so I look for kind of a reshuffling of your calendars. So there will be probably cancellation and then resubmitting for 2025 AIB meetings. Our next meeting will be March 24th, but same afternoon time slot. We are ending an hour earlier today, depending on how many people we have lined up for the agenda. So hopefully we'll maybe have Brooke come in and talk about to address Amanda's question about some pollen sampling or beehives sampling.
The 3036.
Yeah, 3036. I was not remembering that number.
Right.
3036. Testing. And then also I know that we have in the works someone to come in about a developing program for ag plastic disposal. Right. So that's kind of what's on the agenda. If members have other things they would like to see, please let me know. I'm happy to bring people in or track down information that you guys are looking for. I will resend out members to those eligible the new per diem reimbursement form. So please fill those out. So some members are eligible for $50 a day per diem for attending meetings and or any mileage incurred if you're traveling to the meeting in person. So I'll send that out. Look for that in an email. Just we have a new mileage number. That's it. Thanks all. Happy 2025.
Yeah. Thanks.
Thank you all. Good to see you.
Thank you.
Good to see you guys. Thank you.
Thanks. I'm getting ready to send you guys the written report with just what we have so far. We still have more to